to the new protocol called TCP, and that changed everything. Moving to the next slide. Now if you see, this is how network looked right now. And we are talking from 280 devices. Right now, we are talking about nearly 225 billion devices, which means for every one person on earth, there are nearly 3 devices. And if you really see one of the important aspect of it, nearly 50% of network traffic, it is something written as M to M, which is machine to machine, which is something a big contrast from what we had earlier. We had all those nodes where the humans lying on the other side of the node devices, they were communicating with different human beings. But here, it's the devices, it's your mobile, it's your watches, smart bottles, your Alexa, your Google Home, everything which is connected over internet. So in order to support such a big network, that's where the evolution started. From 300 nodes, where the TCP/IP model with certain specifications, how it is evolving over the course of time, how we are able to deal with such a huge inflow of machines. Moving to the next slide. So this is how you have studied networks so far. Different models of network, from the OSI model, which is very famous, 7-layer models. You have gone through about 8 different protocols lying in this model, different layered architecture, to a model TCP/IP, which we talked about, the flagship of internet. In this model, they consolidated certain information, they packed it, and they brought a new model. Moving to the next slide. Now that's very important model for us, TCP/IP model, because it still runs. This is the model on which the internet still runs. And in this model, as an application, right now we are on a teleconference, or you are using mobile, you are using different set of applications on your home automation systems. Anything you do, that is your data. It gets packed based on the transport, whatever we use. If it is a TCP, it picks up the TCP header. If it is UDP, it picks up that header. Then it comes in the next layer, you pick up. So all this is a specified model of different layers, and each header comes at a certain place in the network or a network stack. Moving to the next slide, I will like Venkata to talk more on this slide. Venkata, over to you.
Thanks, Aditya. I hope I'm audible.
Yes.
Yeah. Thank you. So yes, thanks, Aditya, for the wonderful introduction. I think Aditya was spot on. From the early days of the ARPANET, where hundreds of devices were literally connected with a science project, mostly involving professors and PhD students or even master students. The internet has now become more a commodity or a utility like electricity, where if you are without internet for 30 minutes, especially the younger generation gets a lot more restless, and it's like almost become like water or air, so close to that. So the internet has seen a phenomenal amount of growth, and Cisco as a company has been right at the center of that growth. And personally, I traveled to the United States in the late 90s. Earlier as a working professional and later as a student, the audience used to look up to Cisco, to defining the next, big leap of the internet. So Cisco had made a lot of contributions there. And what I will quickly touch upon right now is, very important point that Aditya has highlighted, requirement specification templates, right? That's really, a very powerful term. And what does that mean? What does that mean is, what started as a science project with professors and students, quickly being adopted by a lot of people, no longer the traditional